Okay, so just before the Easter holiday, we talked about visualization. So there are different types of visualization. Statistical graphics and plots, the usual bar charts and line plots and things like that. Infographics and interactive visualizations. So infographics are mostly used in newspapers or more venues where where you don't expect too much of the audience, and statistical plots are mostly used in research to report if your method, for instance, or experiment is statistically different in some way, things like that. Finally, interactive visualizations allow you to interactively manipulate the data, for instance, select a part of the data or be able to zoom in and click on points. Usually that's implemented in the web browser with JavaScript. Then we talked about vector and raster graphics. So raster graphics, with raster graphics, the image is represented by a matrix of pixels, and in vector graphics, you represent the image as a collection of basic shapes, so circles and lines. And actually, in the vector formats such as SVG, you store coordinates of lines, and that allows you to zoom in on a line and still have it rendered clearly. Vector graphics are also preferred if you're writing a paper or a report, and you include a plot. You should always use vector graphics because it's more print friendly. Then we talked about perception and interpretation of graphics. So human have a tendency to group data points based on color, on location, on shape, and because we live, for instance, in a three-dimensional world, we have some bias towards seeing everything in perspective. So you should avoid 3D graphics for at least for statistical plots, things like that. Then we talked about guidelines for plotting different data types. So humans can best distinguish ordinal, nominal, or categorical data and quantitative data points based on position. So position is the most important feature in any visualization. And for instance, for nominal data or categorical data, we're also good at distinguishing in color, in hue, and for more quantitative data, we can better distinguish the length. So for instance, with a line chart or a bar chart, we can compare the length of different bars, and we're quite good at that. And then we discussed some of Tufte's design rules. So annotation of data is really important. Always make sure you have a title, that you label the X and Y axis, things like that. Minimalistic design, so avoid to use 500 and different colors and fonts, and only add to your plot what is necessary. So for instance, if a grid background isn't really adding something to your plot, you should consider removing that. And finally, consistency. So if you have several plots about the same data points or series in your data, you should be consistent and give them the same color in the different subplots, things like that. Then we saw basic plotting techniques, so bar charts, line charts, scatter plots, and tables. So these are still the most used, for instance, in research. We saw some techniques for visualizing high-dimensional data. So usually the basic plots support 2 dimensions, but if you have more dimension, you can consider using nested representations. So that means several subplots. You might, for instance, create a pairwise plot where you consider all pairs of attributes. For instance, if you have a label or a class assigned to each row and several attributes, you can look at the relation between every single dimension and the class attribute, things like that. Heat map, parallel coordinates. And then we also discussed dimensionality reduction using principal components. So that's a useful technique if you have, like, for instance, 10 continuous features, but they're all a little bit correlated, you can compute the principal components and only render the first two principal components, for instance. Then you made exercises with several Python libraries, such as matplotlib, pandas, which actually uses matplotlib behind the scene, and Seaborn, which has some very nice additional plots, especially for visualizing high dimensional data. And finally, also briefly discuss the use of business intelligence tools. So this is a different approach and more suitable for making dashboards. For instance, you might have a website, and then you store the number of visitors that come to your website, and then you can create a dashboard. So that's like a line chart maybe of the number of visitors each day. But using these tools, they connect to a database, and each time the database is updated, the dashboard updates itself. So that's useful if you're in a small organization or a large organization and you want to share some plots, then you can use one of these tools. Okay, that's it for the recap. Any more questions about visualization? Anything I didn't cover? No questions? I'll wait 5 seconds. No? Okay. Then let's continue with the main topic of today.